Today's lesson, prime factorization and greatest common divisor. What do the moon and a dollar have in common? They both have 4 quarters. In today's lesson, we're going to find the prime factorization of a number. We will also do the prime factorization of algebraic expressions that contain variables, and we're going to find the greatest common divisor of 2 or more numbers. Today's Indiana Academic Standard is 7.1.5. Find the prime factorization of whole numbers and write the results using exponents. A prime number is an integer greater than 1 with exactly 2 positive factors, 1 and the number itself. A composite number is an integer greater than 1 with more than 2 positive factors. The prime factorization of a number is writing a composite number as a product of its prime factors. We'll use a factor tree when we do prime factorization. The greatest common divisor, or GCD, is the largest common factor of 2 or more numbers or expressions. Pause the video if you need more time to copy down the notes. Don't forget to record a question. We'll be discussing this in class tomorrow. For number 1, we're going to be determining if these are prime or composite. Remembering your divisibility rules makes this a whole lot easier. Look at 46. Is it prime or composite? Well, it's composite because it has more than 2 factors. It has 1, 2, 23, and 46. For 1b, 13, it's prime because 13 has only 2 factors, 1 and 13. Pause the video if you need more time to copy down the notes. Now let's do the prime factorization for 273. For 273, we know that 3 can go into it because if you add the digits, you get the number 12, and 3 goes into 12. Well, 3 goes into 273 91 times. So 3 times 91 is 273. 3 is prime, so we're going to circle it. But 91 is not, so we're going to branch out underneath it. You have to ask yourself, what can go into 91? 7 goes into 91. 7 goes into 91 13 times. So 7 times 13 is 91. Both of those are prime, so we're going to circle both of those. So the prime factorization of 273 is 3 times 7 times 13. Pause the video if you need more time to copy down the notes. Don't forget to record a question. We'll be discussing this in class tomorrow. Now we're going to be finding the greatest common divisor. I know in 6th grade that you did this by doing prime factorization. That can be very time consuming, and I think it's important that you learn a shortcut method. So if you're talking about the numbers 24 and 30 and you're trying to find the biggest factor that goes into both of them, you can actually start with the number 30 and think about your factors. You can kind of think backwards. Obviously 30 is not going to go into 24. The next factor of 30 that's a little bit less than that is 15 because 2 times 15 is 30. 15 does not go into 24. So then you go to the next factor, which would be 10. 10 does not go into 24. The next factor after that is 6. 6 does go into 24. So the greatest common divisor of 24 and 30 is 6. Now for B, we are going to do the prime factorization method just so that you can see it. But instead of writing it using exponents, we're going to write out all of the factors. So if we look at the number 36, we know that 36 is 6 times 6, and to get 6 is 2 times 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. Then when you factor out your a and b squared, it would be times a times b times b. So we'll write that off to the side. Again, that's 2 times 2 times 3 times 3 times a times b times b. When you think about 81, that's 9 times 9. And to factor 9, it's 3 times 3. So the prime factorization of 81 is 3 times 3 times 3 times 3. And then we just have a b, so it'd be times b. So that's 3 times 3 times 3 times 3 times b. On your notes, you can circle, but I'm going to use a little highlighter. I don't have a circling tool that I can use on the computer. So we're going to circle the things that are common. We have one 3 that's common on the top and the bottom. We have a second 3 that's common on the top and the bottom. And we also have a b that's common. So our greatest common denominator is going to be 3 times 3 times b. Well, 3 times 3 is 9, so we would have the greatest common divisor is 9b. Pause the video if you need more time to copy down the notes. Don't forget to record a question. We'll be discussing this in class tomorrow. For 1a and b, you need to tell me which numbers from 10 to 20 are prime and then which are composite. Go ahead and try these and then check your answer. So pause the video, try 1a and b, then start the video again to check your answers. The prime numbers are 11, 13, 17, and 19. The composite numbers are 10, 12, 14, 15, 16, 18, and 20. Try the prime factorization of A, B, C, and D. I'll solve each one individually, so if you're struggling, you can watch one and then try the other 3. Pause the video now if you think you can do all of them. If you're not sure and you need another example, watch 1 or 2 examples, but please try to do at least 2 of them on your own tonight. Remember that there's more than one way that you can do a factor tree, so if your work doesn't match mine, as long as your final answer does, you're fine. For number 1a, we begin by writing 72. We ask ourselves, what can go into 72? Well, 9 can. 9 can go in 8 times. Neither of those are prime, so we can put a bracket branch underneath both of those. 3 times 3 is 9, so we write down both those 3's underneath the 9. They're both prime, so we're going to circle them, and we're done with this part of the factor tree. 2 and 4 go into 8. 2 is prime, so we circle it, but 4 is not, so we put a branch underneath the 4. The factors of 4 are 2 and 2. Both of those are prime, so we're going to circle it. Now we need to write this prime factorization using exponents. That's going to be 2 to the third times 3 to the second. We typically put our numbers in numerical order from least to greatest. That's why I wrote the 2 to the third first and the 3 to the second after it. Now let's take a look at 121. What can go into 121? 11 can. 11 times 11 is 121. 11 is prime, so we can circle both of them, and we are finished with this factor tree. So the prime factorization of 121 is 11 squared. The prime factorization for 225 is 3 to the second times 5 to the second. The prime factorization of 236 is 2 to the second times 59. Pause the video if you need more time to copy down the notes. Don't forget to record a question. We'll be discussing this in class tomorrow.